The issue of ground fault circuit interrupters, or GFCIs, tripping when connected to uninterruptible power supply, or UPS systems is a well-known one, and several factors can contribute to it. GFCIs are designed to trip when they detect a difference between the current flowing in the hot wire and the current flowing in the neutral wire. This difference is typically caused by a ground fault, which can be dangerous because it can provide a path for electricity to flow through the body. UPS systems typically use a double conversion design, which means that they convert alternating current, or AC, power from the utility into direct current, or DC, power, then invert it back to AC power before sending it to the connected equipment. This process can introduce a small amount of leakage current, which can cause GFCIs to trip. UPS systems often include electromagnetic interference, or EMI, and radio frequency interference, or RFI, filters to reduce electrical noise. These filters can also introduce a small amount of leakage current, which can contribute to GFCI tripping. If a UPS is causing a GFCI to trip, it is likely because of its double conversion design and EMI and RFI filters. This is not necessarily a safety hazard, but it can be annoying and prevent the GFCI from providing protection in the event of a real ground fault. There are several things that can be done to address this issue. Firstly, use a GFCI that is specifically designed for UPS systems. These GFCIs are less sensitive to leakage current, and they are less likely to trip when connected to a UPS system. Secondly, install the UPS system on a separate circuit from the GFCI. This will prevent the UPS system from causing the GFCI to trip, and it will still provide protection for the other equipment on the circuit. Disabling the GFCI is also an option. However, this is not recommended, but it is an option if there is confidence that there are no other potential ground faults on the circuit. Ultimately, the best way to address this issue is to consult with a qualified electrician. They can assess your specific situation and recommend the best solution. As for the question of whether this issue should be addressed by Underwriters Laboratories, or the National Electrical Code, or NEC, that is a matter of debate. Some argue that UL should require UPS systems to meet a higher standard of leakage current protection, while others argue that NEC should require the use of GFCIs that are specifically designed for UPS systems. However, there is no consensus on this issue, and it is likely to remain a topic of discussion for some time to come. Let's delve a bit deeper into the technical aspects of why UPS systems and GFCIs sometimes clash. A GFCI is designed to protect people from electrical shock. It does this by monitoring the current flow into and from an appliance or device. If there's an imbalance, even a tiny one, it assumes that current is leaking somewhere it shouldn't, potentially through a person, and it trips the circuit very quickly, typically within a fraction of a second. This imbalance is what's known as a ground fault. Now, UPS systems, especially those with double conversion technology, introduce some complexities. In a double conversion UPS, the incoming AC power is first converted to DC. This DC power then charges a battery and simultaneously feeds an inverter, which converts the DC power back to AC power to supply the connected equipment. This double conversion process provides very clean and stable power, isolating the connected equipment from voltage fluctuations, surges, and other power quality issues on the incoming AC line. However, this process also creates opportunities for leakage current. Leakage current is a small amount of electrical current that flows from a conductor to ground, even in the absence of a fault. It's a normal phenomenon in electronic devices caused by capacitive coupling and other factors. In UPS, the EMI and RFI filters play a significant role. These filters are designed to suppress unwanted noise and interference from the power line, preventing it from affecting the sensitive electronic equipment connected to the UPS. They typically use capacitors connected between the AC line and ground. These capacitors allow a small amount of AC current to flow to ground, which is the leakage current we're talking about. The amount of leakage current from a single device is usually very small, well below the trip threshold of a GFCI, which is typically around 5 milliamps. However, when you have multiple devices connected to UPS, each with its own EMI and RFI filters, the leakage currents can add up. The UPS itself also contributes to the overall leakage current. This cumulative leakage current can then exceed the GFCI's trip threshold, causing it to trip even though there isn't a true ground fault. It's important to understand that this leakage current, while it can cause nuisance tripping of GFCIs, is not necessarily a safety hazard. It's a normal characteristic of electronic devices with EMI and RFI filters. However, the GFCI can't distinguish between this normal leakage current and a potentially dangerous ground fault, so it errs on the side of caution and trips the circuit. So, what are the solutions? Firstly, using a GFCI specifically designed for UPS systems is a good option. These GFCIs are designed to be less sensitive to leakage current. They have a higher trip threshold, typically around 10 mA or more, which allows them to tolerate the normal leakage current from UPS systems and connected equipment without tripping. However, they still provide protection against true ground faults. Secondly, installing the UPS system on a separate circuit from the GFCI is another effective solution. This isolates the UPS and its connected equipment from the GFCI, preventing the leakage current from affecting it. This requires running a dedicated circuit from the electrical panel to the location where the UPS is installed. This circuit should not be GFCI protected. This is often the preferred solution in critical applications where it's essential to avoid any possibility of nuisance tripping. Thirdly, disabling the GFCI is an option, but it's generally not recommended. GFCIs are there for a reason, to protect people from electrical shock. Disabling a GFCI removes that protection. If you're considering disabling a GFCI, it's crucial to carefully assess the risks and benefits. Make sure there are no other potential ground fault hazards on the circuit. Consult with a qualified electrician before making this decision. Regarding whether UL or NEC should address this issue, it's a complex question with valid arguments on both sides. UL sets safety standards for electrical products. They could potentially require UPS manufacturers to reduce leakage current in their products. This would involve designing UPS systems with more efficient EMI and RFI filters or using different components that generate less leakage current. However, this could also increase the cost and complexity of UPS systems. NEC sets the standards for safe electrical installations. They could potentially require the use of UPS-compatible GFCIs in situations where UPS systems are used. This would ensure that GFCIs provide protection against true ground faults without nuisance tripping. However, this would require electricians to be aware of the compatibility issues between UPS systems and GFCIs and to select the appropriate type of GFCI for each application. Ultimately, the best approach may involve a combination of measures from both UL and NEC. UL could work to reduce leakage current in UPS systems, and NEC could require the use of UPS-compatible GFCIs in certain situations. This would ensure both safety and reliability. In addition to the solutions mentioned above, there are a few other things to consider. Firstly, the quality of the electrical wiring in the building can affect GFCI tripping. Old or damaged wiring can increase leakage currents and make GFCIs more prone to trip. If you're experiencing frequent GFCI tripping, it's a good idea to have the wiring inspected by a qualified electrician. Secondly, the type of equipment connected to the UPS can also affect GFCI tripping. Some devices, such as older computers and appliances, may have higher leakage current than newer devices. If you're experiencing GFCI tripping, try disconnecting some of the equipment to see if that resolves the issue. Thirdly, the grounding of the electrical system is crucial for proper GFCI operation. The grounding system provides a path for fault current to flow back to the source, allowing the GFCI to detect the fault and trip the circuit. If the grounding system is not properly installed or maintained, it can increase the risk of electrical shock and GFCI tripping. It's important to have the grounding system inspected regularly by a qualified electrician. Let's further explore the concept of leakage current and its sources in more detail. As mentioned earlier, leakage current is a normal phenomenon in electronic devices. It's caused by several factors, including capacitive coupling, insulation resistance, and EMI and RFI filters. Capacitive coupling occurs when two conductors are placed close to each other, separated by an insulator. This creates a capacitor, which allows AC current to flow between the conductors even though they are not directly connected. In electronic devices, capacitive coupling can occur between the power conductors and the chassis or ground. Insulation resistance is the resistance of the insulation material that surrounds the conductors. Ideally, the insulation resistance should be infinite, preventing any current from flowing through the insulation. However, in reality, the insulation resistance is finite, allowing a small amount of current to leak through the insulation. EMI and RFI filters are designed to suppress unwanted noise and interference from the power line. They typically use capacitors and inductors to filter out high-frequency noise. Capacitors connected between the AC line and ground allow a small amount of AC current to flow to ground, which is the leakage current. The amount of leakage current from a single device is typically very small, but it can add up when multiple devices are connected to the same circuit. The leakage current limit for most electronic devices is specified in safety standards such as UL and IEC. These standards set maximum limits for leakage current to ensure that it doesn't pose a safety hazard. However, even if a device meets the leakage current limits, it can still contribute to GFCI tripping when combined with other devices. It's also important to consider the type of load connected to the UPS. Linear loads, such as incandescent lights and resistive heaters, generate very little harmonic distortion. Non-linear loads, such as computers, electronic ballasts, and variable speed drives, generate significant harmonic distortion. Harmonic distortion is the presence of unwanted frequencies in the AC waveform. These harmonics can increase leakage current and make GFCIs more prone to trip. UPS systems are designed to handle both linear and non-linear loads. However, some UPS systems are better at handling non-linear loads than others. If you're experiencing GFCI tripping, it's a good idea to check the UPS specifications to see if it's suitable for the type of load you're connecting to it. Another factor to consider is the sensitivity of the GFCI. GFCIs are available with different trip thresholds. The standard trip threshold for a GFCI is 5 mA. However, GFCIs are also available with higher trip thresholds, such as 10 mA or 30 mA. These higher sensitivity GFCIs are less prone to nuisance tripping, but they also provide less protection against electrical shock. It's important to select the appropriate GFCI for the application. In general, a 5 mA GFCI is recommended for residential applications, while a 10 mA or 30 mA GFCI may be suitable for commercial or industrial applications. When troubleshooting GFCI tripping issues, it's important to follow a systematic approach. Firstly, identify the circuit that is tripping the GFCI. This can be done by disconnecting all the loads on the circuit and then reconnecting them one at a time until the GFCI trips. Secondly, inspect the wiring on the circuit for any signs of damage or wear. Look for frayed wires, loose connections, or water damage. Thirdly, test the GFCI to make sure it's functioning properly. GFCIs have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI should trip. If the GFCI doesn't trip when the test button is pressed, it may be faulty and need to be replaced. Fourthly, measure the leakage current on the circuit. This can be done using a leakage current meter. A leakage current meter is a specialized tool that measures the amount of current flowing to ground. If the leakage current is above the GFCI's trip threshold, it's likely that the GFCI is tripping due to excessive leakage current. Fifthly, consult with a qualified electrician. If you're unable to identify the cause of the GFCI tripping, it's best to consult with a qualified electrician. An electrician can perform a more thorough inspection of the electrical system and recommend the appropriate solution. In addition to the technical aspects of GFCI tripping, it's also important to consider the regulatory requirements. NEC requires GFCIs in certain locations such as bathrooms, kitchens, and outdoor areas. These requirements are designed to protect people from electrical shock in areas where they are likely to come into contact with water. However, NEC doesn't specifically address the use of GFCIs with UPS systems. This can create confusion and lead to situations where GFCIs are required in locations where they are likely to trip due to leakage current from UPS systems. It's important for electricians and building inspectors to be aware of the compatibility issues between GFCIs and UPS systems and to select the appropriate type of GFCI for each application. In some cases, it may be necessary to install a separate circuit for the UPS system to avoid GFCI tripping. The long and short of it is understanding GFCIs, leakage current, and best practices is critical for safety.